All right, so check out this nerdy rule right here. And we're just basically going to take what we learned from example 1, and we're just going to beef it up just a tad bit here. And what I mean by that is a last example we did this, right, where if I have some a to the power of 1 over n, then that was the nth root of a, right? So we learned that last example. So now what happens if our fraction, though, if our fractional exponent is no longer a to the power of 1 over n, but what happens if it's a to the power of m over n? Okay, so now that meaning that the m is no longer just 1 right here, okay? But what happens if it's 5 or 7 or something like that? Well, this is another way that we can write this. This is really neat. A to the power of m over n is the same as a to the 1 over n. So, okay, so that's what we did here. But now what you do is that you put that all in parentheses, and we raise it all to the power of m. Okay, just note right here, it says if a to the power of 1 over n is not a real number, then that means that our final answer won't even be a real number. Okay, so we just got to make sure that we're still holding to what we learned in section 8.1. If it's not real, then we just stop and say, oh, okay, there's not a real number here. All right, so let's put this into practice here and see how this works. Okay, all right, so starting with this guy right here. Okay, so you could think of this right here as our n, and think of this little 3 right here as our m. So now we have like a to the power of m over n. See right here? A to the power of m over n. Look, if we just follow the rule right here, see, it's going to be equal to a to the 1 over n. Oops, I'm sorry, we're not doing a though. We're actually going to do the real problem now. So we're going to do 25 to the 1 over 2. And all that then, right, is going to be raised to the power of m, which is going to be 3. Oh, but check it though, y'all. Check it. We know how to do this now. 25 to the 1/2 is just 5. Okay, and I kind of just skipped the part where I rewrite it. So if you don't have to do this part where you say, okay, well that's the same thing as the square root of 25, which then is 5. You can maybe start to do this. You can say, oh, this whole thing is just 5. Okay, but if you need to write it out, then go and do that. Whatever is going to make learning happen for you. All right, and then so if this whole thing became 5, we have to now just raise 5 to the power of 3. Okay, which is 5 times 5 times 5, or in this case, 125. Well, bam! Yeah, pretty sweet. Okay, let's go on right here. So let's rewrite this. This is the same thing as 27, right? This is my n right here, my 3. So I'm going to do 1/3 and raise that all to the power of 2. Okay, so what is 27 to the 1/3, right? So that means the third roots of 27, which is the same thing. So the third root of 27 is just 3, because 3 times 3 times 3 is 27. So if this whole thing became 3, then we have to raise that to the power of 2, and then we just get 9. And cool beans. Let's keep on crack-a-lacking here. Okay, so here we have the whole case here where we have a negative sign, but it's not inside, or I'm sorry, there's no parentheses. So you can think of this as -1 times 16 to the 3/2. Okay, and I'm going to show you what happens when there are parentheses, and hopefully you're going to really start to understand how you approach the problems that don't have parentheses and the ones that do. All right, so let's do this guy. Okay, so if I want to simplify 16 to the 3/2 power, that's the same thing as 16 to the 1/2. Raise that all to the power of 3. Well, this means the square root of 16, right? Which is just 4. So this right here became 4. And then I do 4 to the power of 3. 4 to the power of 3. Okay, and 4 to the power of 3 is 4 times 4 times 4, or 64. Okay, but we can't forget about this little negative guy. So we have to multiply this by -1. So that means our final answer is -64. Now, what about this dude right here? Well, what about that dude? Well, let me show you, all right? So since we have parentheses, it means the whole number negative 64 is being raised to 2/3, which means that when I rewrite it, the negative is going to follow the 64. I can't separate it like this, okay? So now this is going to become negative 64, okay? The whole thing, negative 64, you raise the whole thing to the power of 1/3, okay? And then, I know it's going to look kind of weird here, but then I'm going to do the whole thing, it has to be squared. Okay, so check that out here. So the whole thing, negative 64, is being raised to 1/3. And the reason why I put parentheses inside of here is that if I didn't do it, then that means I can separate it, but we're not supposed to separate it here. We're actually supposed to do, we're taking the third root of negative 64. Okay, so what does this mean right here? Okay, so again, this means the third roots of negative 64. Okay, and we can do that right there. Remember, because this is an odd number, and if a is negative, we can do that one. So this right here is going to be negative 4. Okay, so what's inside of right here is just negative 4, because negative 4 times negative 4 times negative 4 is negative 64. And then we're going to square that whole thing. We have to still do this. So the negative 4 times negative 4 is going to give us a positive 16. Okay, so if you have to rewind that and look at that again, you can do that. All right, and then part E. Again, the negative sign is inside the parentheses, so which means that when we rewrite it, we have to keep it in with the 36. So this means negative 36 to the power of 1/2. Okay, but then I have to raise that whole thing to the power of 3. Okay, so let's do this part. Okay, so this part right here means the square root of negative 36. Whoa! Remember, this number right here is 2, right? Is it possible, if this is an even number and an odd number inside the radical, is this possible? No! It's not possible, right? So we're just going to say that this answer does not have a real answer. So we're going to say no real number, or no real answer. Okay? Not possible. No. And that concludes that example.